implementing the assignment operator, we need to always return a reference object. Then whenever we are entering the this function, we need to check if this pointer, so this current object and the past object are both the same. We can like check by the address of this is nothing but a pointer, and we can check it using the address of RHS object. So we can check this. If both are same, we can just return start this. So if it is not equal to same, then only we are going to do. So what here we are going to do is we are moving. So this this will have pointer. So pointer is nothing but RHS dot pointer ptr, and this RHS dot ptr is nothing but null pointer. Okay, and before assigning this we need to make sure if pointer, if it has any memory allocated, then we need to delete that, and then only we need to assign. So this is not mandatory here, this pointer, or if we simply use pointer, both are same. So I am removing this arrow. So this is about copy assignment operator, sorry, move assignment operator. So now we need to do move constructor. So move constructor, here I am doing. So move constructor, so the syntax is I need to get this as R value reference. I need to get this as R value reference, and here also we need to make sure three things. Like here we don't need to know, like here there is no return value, so we can ignore the first point. And the second point, check if both are same. Here also it is not possible because the object is newly created, so we don't need to check both are same. And this delete also we don't need to check because this is the new object we are creating, so it don't have any memory allocation, so that also we don't need to delete it. So we don't need to make sure these three things. You can just do this pointer equal to RHS dot pointer, RHS dot pointer equal to null pointer. Only this is enough. So this is very simple. Move constructor. Then we need to define get member function. So this get member function, okay, get member function. So this get member function won't modify anything in the class, so I'm making a const member function. What it will return this get, it will return a pointer, raw pointer. So return ptr. So this is the get, then reset. This is simple. Okay, now I'm going to do reset. So reset won't return nothing. So if we don't pass anything, then it should delete the the memory allocation. If pointer not equal to null pointer, then it should delete it. So this is reset. Then if we pass any memory like a pointer, then it need to allocate that to the pointer. It need to assign that to pointer. So this is if we don't pass anything, and if we pass, we need to assign this with the passed parameter, but we can combine that both. Instead of writing another reset function with parameter, we can make it as default t star p equal to null pointer. So equal to, so the both cases are handled here, both without parameter and with parameter, both are handled in the same function. If we have passed anything, then that will be assigned to pointer. If we don't pass anything, null pointer will be assigned. Okay, so reset is also handled. So now we need to overload the dereferencing operator. So dereferencing operator, if we dereference any pointer, what it will return? It will return the object. So here object is nothing but t. We don't know the object. It is templateless. So return object is t, and I am overloading the star, this dereferencing operator, return star ptr. So here, instead of returning the value, I am returning reference so that it will be efficient. So why I am returning reference object here is, when we dereference any object, it will create object. Instead of returning it by value, I am returning it by reference so that it will be efficient. Then so this is also done. Now it should be able to create any data type, like user defined data type also. Since we have declared it as a template class, it should be able to create with the user defined class also. So I am creating an class A, which is of user defined. Here I am calling the function cout a file is called, and just simply a, and here a of a of a. Okay, so I'm creating constructor also. So here this will be called, this constructor should be called. So here I'm just printing to make sure if it is getting called. A constructor called. Okay, so a constructor is called. Okay, so now we need to do the arrow operator. Now we need to overload the arrow operator. So arrow operator, what it will do, what should it do? So arrow operator, it should return the pointer. So the raw pointer present inside this class, it should return that, because using that pointer only we can use the arrow operator or dot operator. So we can just return the pointer present inside that. So now the member variable can also be called, or member function also can be called. So both can be called by just overloading this arrow operator. Then finally we should be able to use this inside the if condition or while condition. For that we need to overload the bool operator. So bool operator is a special operator. So the syntax is operator bool, and this is a constant number. So I'm using this const here. All are const only, so I'm using const. Okay, reset is not const. Get is also const. Yeah, that's it. So this bool should return true if the pointer is not null, and should return false if it is null. So now I am using this conditional operator. If it is null means it should return false, and if it is not null means it should return true. So this is what I have used here. So instead, if we use instead if of p, if of q, it should return true or false. If for the point inside the q is null, it should return false. If it is not, then it should return true. So now let's try running this program. So I'm just printing some statements to make to to make it for better understanding. Unique pointer constructor is called unique pointer. Move constructor is called. Then here move assignment operator is called. Then that's it. So now I'm going to run this program. Let's see what happens. Oh, getting many errors. Compile errors not equal to. Now I'll try running this b equal to p not allowed. So if you see line number 82, it's not allowed. Let's see what is the line. See, it is not allowed. It should throw compile error. That's why I have written the statement. So it is successfully returning compile. So I will comment this out. Why it is returning not allowed means delete. This is deleted function. See, I have deleted this operator. So this will clearly show the user that we should not assign to another. Uh, we should not assign a unique pointer to another unique pointer. So ownership is unique. To make sure that to user, I have deleted this. So now we will run this program. So here if you see copy constructor is also not allowed. I will comment this also. So this is expected only. And see out. Okay, this is for function actually. So it is returning void. That's why we are getting error. I will try to run this. So it is successfully compiling. So now let's see this unique pointer constructor is called. For p it is called, p1 it is called, then p equal to move p1. So move assignment is getting called. Now p3 move constructor is getting called. Now and then reset is getting called, get reset. Then here I am dereferencing p and printing it. So 8 is getting printed. So if we see 8, I didn't add new uh, new line. That's why it's somewhat congested. So p. So I have reset with 8. So if you see 8 is printing properly. Now then a constructor is getting called. So here if you see unique pointer with a user defined class is also called. So there also we are able to create unique pointer for that class also. So if initially a is getting constructed, then q is getting constructed. So if you see the order, a constructor is called, then unique pointer constructor is getting called.